Morning and hello everyone. Welcome. Uh, you remember, you know that our lessons are brought to you by Smart Camps in line with the curriculum by the Department of Basic Education, sponsored by VT Africa Holdings and companies. Uh, Today I have an activity that we're gonna interact together with, that we're gonna work on after our lesson. I'm gonna need you to log into hellosmart.com in order to take part in the assessment. You're going to sign in as a guest, and the class ID you are going to use will be 598751. That will be the class ID you're going to use such that we can interact. I get to see your responses, and you get to see my workings as well. So we continue with mixtures and matter and materials. As you know, this chapter forms a huge part of chemistry and sciences in general. Last time we were looking at mixtures. We defined what mixtures are. We looked into how you can combine or mix different substances. We looked at mixing solids and solids, liquids and solids on all those varying substances. Today we look at how we can separate them. So we are going to look at methods of physical separation of mixtures. Why are we saying physical separation of mixtures? You remember, because mixtures are those that do not have any chemical reaction or chemical bonding between them, meaning they combine but can be physically separated, right? Let's look into these methods. The first one we're going to look into is hand sorting. Hand sorting, think of a glass bowl filled with varying colored 4 beads, and you're trying to separate them by color. How would you go about that? You would separate these beads by color by virtue of picking out those that match and putting them aside, picking out those that match and putting them aside. And that we call hand sorting. You are separating a mixture, this being our mixture, and you're going to separate them by color, by choosing each one by virtue of their characteristic, say by color, say by shape, say by size. And you're going to hand pick them out and separate them. This would be your mixture, and you'd be separating it by hand picking or by hand sorting. And this is one way in which a mixture can be separated into its components. And I'm saying your mixture can be separated by hand sorting by virtue of its properties, right? You'd be looking at, am I looking to separate these because of color, or because of size, if they have varying size, or because of shape, maybe they have varying shape. You have squares and circles and all these stars and all these other shapes. So you're going to be hand selecting or hand sorting these and choosing one from another. And that's called hand sorting, right? Easy enough. You must have done this on numerous occasions. Let's look at another one. sieving. And as you see this beautiful image on the board of a kitchen sieve, where you are separating flour whilst you're cooking or baking, rather. As you separate the flour, you're looking to put some air between your flour. Yes, you'd be doing that. So sieving in terms of science is separation of solids by virtue of their size, the size of those solids. You're going to separate a mixture. Here's our mixture. And you're going to separate the mixture by virtue of the size of the particles that you're dealing with, or the size of the particles in your mixture. So here are your particles. Say this is your mixture, and here are your particles in different sizes. In showing the varying sizes, I will use different colors to indicate those different sizes, right? It's our mixture having different sizes. And then we are having our mixture having different sizes. So we are going to take a sieve. A sieve is, excuse me, a sieve is a material that has holes of particular size. And what happens is it only allows particles of a particular size to pass through it, and it will hold up or trap particles that are too big for those holes that are on that sheet. So a sieve will be a sheet with holes, right? A sieve will be a sheet with holes of particular sizes, and those holes with those particular sizes will hold up particles of a particular size and allow particles that are smaller than those holes to pass through. And in that case, you'd be having layers like that, these being your sieves of varying particle sizes, and small particles will be allowed to pass through whilst large particles will be held up. As those small particles pass through, you'd be separating this mixture in terms of their size, meaning the bigger or the larger particles will be held up while the smaller ones get to pass through these holes on the sheet. And you'd be then separating them by their size. So clearly that means we need, in this case, we'd be having sieves of different sizes. Here, we'd be having sieve 1 of a particular size, sieve 2 of a particular size, and sieve 3 of a particular size. And each one will allow particles of a particular size to pass through it and holding up certain others of a different size. Meaning in layer 1, you'd be having size 1. In layer 2, you'd be having size 2, depending on the size of your sieve. By size of your sieve, we mean the holes in your sieve, right? So you would be then separating your mixture by virtue of the size of those solids, right? And this means the smallest particles will be at the very bottom. whilst the largest will be at the very top. Whilst the largest will be at the very top. Why is this? It's because the sieve, how it works, it holds up particles that are larger than the sieve size, and it allows through particles that are smaller than the sieve size to pass through, and they will trickle through or pass through, and the smallest will go to the very bottom, and the largest will be held up at the very top. Makes enough sense, doesn't it? Let's look at another process by which we can separate the mixture. So we have now seen two methods in which we can separate solids by virtue of their size in sieving, by virtue of their size or color or shape by hand sorting. So what happens when you have a liquid mixed with solids? How can you separate those? You cannot use a sieve, you cannot use hand sorting, but what you can use is this next method, which is called filtration. And with filtration, what happens with filtration is we are separating solids from liquids, right? Say we have a mixture here, our nice little mixture in a beaker, and we're looking to separate these solids from the liquid in which they are immersed. How do we go about that? So we are going to take a funnel. A funnel is a glass that has a tube like that, and it is very small in diameter here. And just as you see in the image, you put your filter paper here. You will line your funnel with filter paper there. You will line your funnel with filter paper there. And as you line your funnel with filter paper like that, going around our funnel with filter paper like that, what will happen is the solid particles will settle will start to settle, and water or the liquid in your solution, in your mixture, will drip out at the very bottom. Bit by bit, it's a very slow process, and the liquid will drop out, and the solids will be held up or will pile by your filter paper or by your funnel. And this is how the end product will look like, where you have your liquid that has managed to pass through there in small bits, and the solids being able to accumulate like that there. And water will be pulled down by gravity, of course, will be pulled down by gravity, and will collect or accumulate at the bottom, whilst your solids will collect along your funnel. And this needs to be, your funnel needs to be very small, as we discussed. Why is that? Such that the solids can stay up whilst your water drips through, right? And this is one way you can separate liquids from solids. It's a slow process, but it's an effective process because your solids will remain at the top while your liquid is collected separately, and you have differentiated or separated your liquids from your solids, which would be much harder to do if you're hand picking, right? Hand sorting or hand picking. So now let's look at another method of separation. Another method of separation is called magnetic separation. What happens with magnetic separation? Here we'll be looking at a mixture of solids. Say we are at the beach, a nice beach, and on the sand you lose your coin or your money. Here's your money. It's in the sand, and all of this is sand. All of this is sand. All of this is sand. So your coins are covered by sand and you can't see them or find them. How would you go about by finding them? You can easily put a magnet, move a magnet on top of these. There's our magnet. You can move a magnet on top of our sand, right? In moving our magnet on top of our sand, what happens? Our coins will be attracted to our magnet because they are magnetic and they will hold up, whilst the sand, because it does not attract or does not react to the magnetism of the magnet, the sand will remain while the coins separate and get pulled up by the magnet, right? So this is one way of separating the sand from the magnets. And here's a good example where you have sulfur and iron filings. Iron filings are just small spheres of iron or of metal. And once these are mixed together, here they are mixed together. How do you separate the iron from the sulfur? Sulfur is just, you can think of it as just soil, whilst you have iron as metal. If this mixture, same as with the coins lost in our beach sand, you can have the same separation happening here, where you put a magnet over our mixture. You put a magnet over our mixture, and the iron filings will be attracted towards our magnet because metals, as we know, are magnetic, right? They are pulled towards magnets. And then in them being magnetic, we can use that property that they have in order to allow us to separate magnetic materials from non-magnetic materials, right? And that's magnetic separation. We are separating solids by virtue of their magnetism. Are they magnetic? Are they not, or are they not magnetic? And in them being magnetic or not, we can thus separate them into those that are magnetic and those that are not by placing a magnet over our mixture. Let's look at another method in which we can separate mixtures. So we have evaporization. What is evaporization? Evaporization, as you remember in phase change, we were discussing about we discussed it as the boiling of materials, right? they evaporate or they boil, which is the phase change from liquid, yes, to solid, to gas, right? From liquids to gas. So we are having a phase change from liquid to gas. But how does that help us separate materials? So think of it this way. If you are having two liquids in a mixture, and the liquids have different boiling points. You remember we discussed boiling points when we're discussing phase change, and we namely focused on water. And we described the boiling point of water to be 100 degrees Celsius. We said water evaporizes at 100 degrees Celsius. And we discussed how this property, the boiling point, is unique to materials. You remember that. So it being unique to materials, it means other materials will evaporize or boil at different temperatures. So having a mixture that has water, say ethanol as well, ethanol that has a BP or boiling point of 78 degrees Celsius. How can we use this property that they have as scientists to separate a mixture that has water and ethanol? How do we go about that? Easy. This is how we do it. We are going to boil this mixture. Here's our mixture having ethanol and water. It's our mixture. It has ethanol and it has water. So once we put a flame underneath this, what happens? Let's put a flame underneath that. The temperature will start to increase, right? It will go from whatever temperature it is, let's say room temperature at 25 degrees, and it will start to increase. It will get to 50 degrees Celsius and continue to increase. Eventually, it will get to 78 degrees Celsius. And what happens at 78 degrees Celsius? This is the boiling point of ethanol, right? So at this state, our mixture, being 78 degrees, this means that ethanol will start to evaporate. It will start to boil. And if ethanol is starting to boil, that's ethanol. It will leave our liquid solution as a gas in gaseous state. Ethanol will leave our solution or our mixture as a gas in a gaseous state, leaving behind our H2O, which is still in the beaker as liquid because it has not evaporized yet, because it only evaporizes at 100 degrees Celsius. So our liquid will still, our H2O will remain, but our ethanol would have evaporized out. Our ethanol will be existing as gas. And in that way, we would have separated our mixture in terms of the H2O and ethanol. We'd be having now H2O and ethanol separately when we initially had a mixture of them two in one beaker. So that's one way to exploit now the boiling point. We are now exploiting the boiling point, which is a property of our materials. We are exploiting their boiling points such that we can have a separation in our mixture. Substances have unique boiling points, and we're going to use that property in order to separate them. And this introduces another separation method that is greatly used in sciences, and that is a step forward from evaporization. What do I mean by a step forward? I mean, in the next method I'm going to show, we use evaporization, but what do? We collect our gas. This gas that has evaporized out, we collect it and we do not lose it. As soon as it evaporates out, we collect it and we store it, and we have two separate liquids now, or two separate substances. We'd be having our ethanol in one beaker, we'd be having our liquid in one beaker by using the virtue of their boiling points, by using evaporization still. And what am I talking about? I'm talking about distillation. Distillation, we are separating materials using evaporization. Say we have our mixture there in a beaker. We put heat to this mixture, and by putting heat to this mixture, the temperature will start to increase nicely. And as the temperature increases, what happens? Because these mixture has substances with different boiling points, they will start to boil at different temperatures. Once we hit the temperature at which the substance is at its boiling point, the first substance will start to boil out, right? It will start to evaporate. And as it evaporates out, and here we're going to collect it. We're going to collect it here, but in having the gas here, the gas is passing here, we're going to cool this gas. Because it is at its boiling point, we're going to cool it down by using water. So we're going to put water around this tube of which the gas travels. We're going to put water around this tube of which gas travels. So here's our water, cool water around the tube by which the gas travels, and the gas will now cool down, of course. And once it starts to cool down, it will now start to what? Condense. You remember first change? It will start to condense. It will transform from gas back to liquid, because now it has been cooled down by this water that we supply here, right? And once it starts to condense, we collect it in a separate beaker, and there we are having our substance that was separated from the original mixture by vaporizing it and allowing it to pass through a cool surrounding such that it can condense and now be collected again. We vaporize, we cool it down, we collect it again. And that's distillation, right? And distillation is used in a great number of ways in industry. An example being crude oil. Crude oil is collected as a natural resource, and from it we use distillation to get a range of fuels that are used in different ways, in different components. We are going to take our crude oil, because we know it's a combination or it's a mixture of different substances. We're going to put heat to it, right? And by virtue of the difference in boiling points of the different materials, we are going to have this separation coming out, and this will allow us to have the different liquids coming from it. What we collect from crude oil is jet fuel, petroleum, car oil, and what remains in the end is tar. And those methods are those that we're going to look at today, for today. And a short 2-minute activity on those methods that we've just discussed, just to be sure we do not have too many confusions or misconceptions. And here's our activity, and this is how you're going to be able to interact with me on the activity. You are going to sign in on HelloSmart, enter your name, and enter the class ID I showed you, and you can interact with me or take part in this activity by yourself on your cell phone, on your computer, on your tablet. As long as you have internet connection, you should be well and fine. So try out that activity, and you should be able to get results immediately as soon as you finish with the activity. It's a nice little activity that will show us how we can use these different methods of separating mixtures. Thank you very much. Enjoy the activity, and we'll continue tomorrow on matter and materials, on separation of materials, and with what we can do with waste. Because remember, when we are separating these, we have waste, and what we can do with waste such that we minimize the impact on our environment. Thank you very much.